IIM K BMS AT, which is the entrance exam for BMS program at IIM Kozhikode, is going to be conducted on 22nd of June 2025. We are coming up with a crash course wherein we will be covering the whole syllabus that is going to be asked in the exam. This crash course is going to have 30 sessions and each session will be delivered to you on this YouTube channel itself daily at 9 pm. After this crash course is done, we will be providing you with the workshops that will definitely help you train for the exam. As of now, we know that the exam is going to have only QA section and VA section. There is no LR section asked in the exam. But the paper pattern of the exam is not known. As soon as we come to know about the paper pattern, we will definitely deliver 3 to 5 mock tests to you guys as well. So make sure that you subscribe to this channel and inform your friends that this course has started and they can benefit from it. And now let us start learning. In this video, we are going to look at the basics of inequalities and modules, followed by the exam level questions. So basics of inequalities. So we all know that how an inequality looks. This is equality is equal to, correct? Inequality is either greater than or less than, greater than equal to, less than equal to, like that. Okay. Now, if x is greater than y, and then there is a value b, which is positive. If I add this value, x plus b, y plus b, the inequality does not change its nature, or inequality remains as it is. Okay, for example, 10 is greater than 5. If I add 10 plus 3 and 5 plus 3, inequality will not change its nature, it will remain as it is. If we subtract this positive value, x minus b, y minus b, still inequality won't change its nature. Again, 10 greater than 5. So if I do 10 minus 2, 5 minus 2, the inequality does not change its nature, it remains as it is. If I multiply by this positive value, still inequality does not change its nature. 10 into 3, 5 into 3, still 10 into 3, 30 is greater than 5 into 3, 50. And if we divide by this positive value, still inequality won't change its nature. So 10 divided by 2, 5 divided by 2. So 5 is greater than 2.5. Inequality will not change its value. So in an inequality, we can add, subtract, multiply or divide a positive value without changing the nature of the inequality. But what if b is negative? So let us say we have x less than y now. Okay, and b is negative. If I add this negative value, inequality again won't change its nature. For example, 5 and 15. Okay, if I add a negative value, so 5 plus minus 2, 15 plus minus 2, still the sign will remain as it is, correct? If I subtract this negative value, so x minus b, y minus b, inequality again won't change its nature. For example, 5 less than 15 we have already. Now 5 minus minus 3, 15 minus minus 3. Still, this will become 8, this will become 18. 18 is greater than 8. So inequality is not changing its nature. Okay. But if we multiply by this negative value, the inequality will change its nature. For example, 5 is less than 15. If I multiply 5 by minus 2 and 15 by minus 2, what we will have? We will have minus 10 and minus 30. Obviously, minus 10 will be greater, no? So inequality will change its value. Next thing, if I divide by this negative value, still the inequality will change its nature. So 5 upon minus 2 and 15 upon minus 2. This is minus 2.5 and this is minus 7.5. Minus 2.5 is obviously greater than minus 7.5. Yes or no? We understand a number line, right? So minus 2.5 will come somewhere here and minus 7.5 will come somewhere here. The value to the right is greater on a number line. Value towards the right are greater and value towards the left are smaller. So understand the number line, and on the basis of that, these are the inequalities. So in short, if we have to comment, if there is an inequality and it is added or subtracted or multiplied or divided by a positive value, it does not change its nature. And if there is an inequality and we add or subtract a negative value from it, inequality does not change its nature. The only change happens when an inequality is multiplied or divided by a negative value. This is what we understand from inequalities. Okay, we are going to work on these inequalities to understand how the questions can be solved. Moving forward to quadratic inequalities. So let us say ax square plus bx plus c equal to 0 or greater than equal to 0, something like this, is a quadratic equation or quadratic inequality, and alpha and beta are the roots of the quadratic inequality. Alpha and beta are the roots of the quadratic inequality. Then we will be able to write this inequality in the format of x minus alpha into x minus beta. Correct. Now there can be four possibilities. X minus alpha greater than 0. These are the roots of the equation. Okay. In quadratic equation, we have already studied how to find out the roots of the quadratic equation. Same method we will be applying here. Now there can be four possibilities. X minus alpha, x minus beta greater than 0, or x minus alpha, x minus beta greater than or equal to 0. X minus alpha into x minus beta less than 0, and x minus alpha into x minus beta less than equal to 0. Okay, we are going to look at all these four possibilities and try to find out what will be the range of x for which the quadratic inequality holds true. Okay, so we are trying to find out range of x for which the quadratic inequality holds true. Okay, let us try to understand. So we have x minus 2 into x minus 3 greater than 0. If we have something like this, so we plot a number line. So that it's 2 and 3. We can take any value between this. So these are the four ranges: minus infinity to 2, 2 to 3. In fact, three ranges: minus infinity to 2, 2 to 3, and 3 to infinity. These are the three ranges which we have. Let us try to substitute any value from all these three ranges and see whether the inequality works or not. So minus 2 to minus infinity to 2, the value can be 0. Okay, x value can be 0. If x is equal to 0, this will be minus 2, this will be minus 3, which is positive 6. Is it greater than 0? Yes, it is greater than 0. Very good. Then, so for this range, the inequality works, or for this range, the inequality holds true. Now consider any value between 2.5. So if I put x is equal to 2.5, so 2.5 minus 2 is 0.5. 2.5 minus 3 is minus 0.5, which is equal to minus 0.25. Is it greater than 0? No. Minus 0.25. Is it greater than 0? No. So for this range, the inequality does not hold. Now 3 to infinity. 3 to infinity again, we can consider any value. Let us say we consider x is equal to 4. So 4 minus 2, 4 minus 2 is 2, 4 minus 3 is 1, which is 2. Is it greater than 0? Yes, it is greater than 0. So this range works. So what we can say, x belongs to minus infinity to 2 union 3 to infinity. Okay. Now, if I have to say that what will be the range of x here? So x belongs to minus infinity to alpha union beta to infinity. Okay, this is the range of x in which the inequality will hold true. What if x is greater than or equal to 0? X minus alpha, x minus beta is greater than or equal to 0. For example, x plus 5 and x minus 7 is greater than or equal to 0. Let us try to plot this. So we have positive 5, so we'll take negative 5 over here. Why? Because in which ways, how do we used to do it? X plus 5 equal to 0, so x is equal to minus 5. Yes or no? So same thing we are saying here. So x, now here we have minus 5. X minus 7 equal to 0, then we used to say that x is equal to 7. So then same value 7 will substitute it. Now again there are three ranges. For example, minus infinity to minus 5, minus infinity to minus 5, minus 5 to 7, and 7 to infinity. Okay, let me try for 0, because if I try with 0, I am able to solve it quite easily. So if I put the value of x is equal to 0, I'll have 5 into minus 7, which is minus 35, which is greater than equal to 0. Is it true? No, it is not true. So for this range, the inequality will not work. Okay. Now, if x is equal to, let us say I put as minus 7. So minus 7. So this is minus 7 plus 5. It's minus 2. And minus 7 is minus 14. It is positive 28. Is it greater than equal to 0? Yes, it is greater than equal to 0. So for this range, the inequality works. Now, if I consider any value greater than 7, between 7 to infinity, let us say I consider 10. If I put x is equal to 10, then 10 plus 5 is 15. 10 minus 7 is 3, which is 45. Is it greater than equal to 0? Yes, it is. So for this range also, the inequality works. Now, what will be the range for x? X belongs to minus infinity to minus 5, closed bracket, union, closed bracket, 7 to infinity. Okay. Now, what do we understand by round bracket and closed bracket? Let us try to understand that. So, whenever we have A, B, round bracket, so all values between A and B except A and B. Okay. So, this is the range. For example, if I say 3 to 7, so 3.5 will work, 6 will work, 4 will work. But 3 will not work. 3 is not included in the range. 3 is not included in the range. 7 is not included in the range. Okay. But now when we consider round bracket A comma B, all values between A and B, including A and B. So let us say I have 5 to 10 close bracket. So then 5 will also work, 10 will also work, 9 will also work, 8 will also work, and everything. Okay, all these values will work. something like this. If we have minus 3 to 7, this is round close bracket and this is round bracket, then minus 3 will not work, minus 4 minus 2 will work, and 1 will work, 7 will also work. Why? Because 7 is included, minus 3 is not included. So whenever that value is included, then we use closed bracket or square bracket. Whenever that value is not included, we use round bracket. Now you must be asking, why is this a round closed bracket in front of minus 5 and 7? Are these values included? So yes, minus 5 is included, 7 is included, because these values will satisfy the inequality. For example, if I put x is equal to minus 5, this will give me this bracket as 0, this bracket as minus 12, which is equal to 0. Is this greater than equal to 0? Yes, it is equal to 0, no? If I put x is equal to 7, I'll have 12 into 7 minus 7 is 0, which is equal to 0. Is this greater than equal to 0? Yes. This value also satisfies the inequality. Okay. If this method is understood to you, good. If you don't understand the method, just simply write this greater than or equal to. If we have this equal to sign, then we have this closed bracket. If we don't have this equal to sign, just like here, we use the round brackets. Again, I am repeating, if we have this greater than equal to wala sign, then we use closed brackets. And if it does not have that equal to wala sign, we use round brackets, just like we did here. Okay, simple explanation. Now, minus infinity and positive infinity can never be taken into closed bracket. Okay, they can never be taken into closed bracket. They'll always be in round bracket, because you cannot contain infinity. No, you cannot include infinity. Infinity is what you think and beyond that. Okay. What would be the range here? So x belongs to minus infinity to alpha, close bracket. Here, as it is minus infinity, we use round bracket, union beta to infinity. Beta to infinity. Okay, write this down. Then we'll move forward. Moving to next case, x minus alpha into x minus beta less than 0. So x plus 5, x minus 3 is less than 0. What we will do, we will plot it. These are 3. This is minus 5 is the root, 3 is the other root. Okay. We try for any value. If you have observed, I generally try for 0. 0 will lie in this range, minus 5 to 3. 0 will lie in this range, minus 5 to 3. So if I substitute x is equal to 0, this will become 5 into minus 3, which is minus 50. Is it less than 0? Yes, it is less than 0. So this range works. Now, the ranges, they are always acceptable alternately. So if this range is acceptable, this range will not be acceptable. This range will also not be acceptable. They are acceptable or not acceptable alternately. Okay, let us try. Let us say if I put x is equal to minus 6, which is in this range, minus 5 to minus infinity or minus infinity to minus 5. If I put x is equal to minus 6, this will become minus 1. Minus 6 plus 5 is minus 1 multiplied by minus 6. Minus 3 is minus 9, which is positive 9. Positive 9 less than 0? No. That is where it is not satisfying the inequality. If I put any value in this range, let us say 5, then x is equal to 5. If I put, this will give me 10 into 5 minus 3, it's 2, which is 20. Is it less than 0? No, it is not less than 0. And that is why this range will also not be acceptable. So x belongs to which range? It belongs to minus 5 to 3. It belongs to minus 5 to 3. Okay, if we have to apply it over here, x belongs to alpha to beta. Next case is x
plus 7 and x plus 4 less than equal to 0. Less than equal to 0. What we have? We have minus 7 and minus 4. We have plotted it on a number line. What we generally do? We try with 0. If I put x is equal to 0, if I put x is equal to 0, this will be 7 into 4, which is 28. Is it less than equal to 0? No. So this range will not work. If this range does not work, this range will definitely work and this range will not work. Okay, this range will not work. Okay, now try for the other values. So let us say if we put x is equal to minus 8. So minus 8 will come here. Minus 8 will become minus 1. Minus 8 plus 7 is minus 1 into this is minus 8 plus 4 is minus 4, which is positive 4. Is it less than equal to 0? No. So this range will not. So as I told you, the ranges acceptable for x will be alternately acceptable and not acceptable. Okay, and wherever we have equal to sign, less than or equal to or greater than or equal to, we have to use closed brackets. And infinity cannot come in closed brackets. Okay, so x belongs to, here x belongs to alpha to beta closed brackets. Okay, moving forward to modulus. Basics of modulus. So what is mod x? Mod x is equal to x if x is greater than or equal to 0. And mod x is equal to minus x if x is less than 0. Okay. So for example, mod of minus 4 is also 4 and mod of 4 is also 4. It is the absolute value. It helps you make the value. It helps you give you the absolute value of any term. Then what are the properties? Mod x is always positive. Always it is positive. Then mod x minus y is equal to mod y minus x. Okay. And then mod x into y is equal to mod x into mod y. Perfect. Okay. So these are the properties. Now mod x plus y is equal to mod x plus mod y. It can be equal to this or it can be less than this. Okay, it can be equal to this or it can be less than this. So these are the small properties. We don't have to get into it. We have to understand what is mod. So for example, mod 5x plus 3 is equal to 33 is given to us. It will open in two fashions. One is 5x plus 3 is equal to 33 and other one is minus of 5x plus 3 is equal to 33. Okay, it will open in two fashions. Now the complexity will increase when we combine modulus and inequality. We'll look at that. Now some special concepts of algebra. A raised to n plus b raised to n will always be divisible by a plus b when n is odd. When n is odd. For example, 20 raised to 90 plus 21 raised to 90. N is odd, no? And the powers should be same. Then this term is definitely divisible by 20 plus 21, that is 41. That is 41. Then a raised to n minus b raised to n will always be divisible by a minus b. It will always be divisible by a minus b. So understand this thing. Irrespective of the power, whether it is even or odd, a raised to n minus b raised to n will always be divisible by a minus b. And a raised to n minus b raised to n will always be divisible by a plus b if n is even. Okay, so 25 raised to 13 and 26 raised to 30. Okay, in fact, we have to take subtraction. Okay, 25 raised to 13 minus 24 raised to 30. Will it be divisible by 25 plus 24? No, because the power is odd. If the power is even, then it will be divisible by 25 plus 24. It will be divisible by 25 plus 24. We have to make sure that this is true. Next thing which we have to understand is that for a given sum, the product will be maximum. For a given sum, product will be maximum if all the values are equal. For example, a plus b plus c is equal to, let us say, 30. Then a into b into c will be maximum. It will be maximum only when all these values are equal. Only when a is equal to b is equal to c, which will make it 10 into 10 into 10. Okay, we will get maximum. If we move away from the mean, or if we move away from their average, then the product will start decreasing. The maximum value will be obtained when all the values are equal. Next, for a given product, sum will be minimum. Sum will be minimum if all the values are equal. Now, understand this. Let us say a into b into c is equal to 343 is given to us. Then a plus b plus c will be minimum. Will be minimum only when a is equal to b is equal to c. Okay. Remember these two properties. We'll be needing it a lot while solving the questions for it. Okay. So write this down. I'll be explaining you two more properties. Next is arithmetic mean is always greater than or equal to geometric mean, which is always greater than or equal to harmonic mean. Okay, let us say there are two values a and b. Their arithmetic mean will be a plus b by 2. Geometric mean will be root ab, and harmonic mean will be 2 upon 1 plus a plus 1. 1 by a plus 1 by b. And this will always be like this. Okay? Next important parameter or next important concept is a upon 1 by a will always be greater than or equal to 2, or a plus 1 by a minimum value it's 2. Okay, minimum value is 2. Now that we have got the minimum value, you can substitute. So 1 plus 1 by 1 is equal to 2. This is the minimum value. If I, let us say, substitute for 0.5 plus 1 upon 0.5, which is 0.5 plus 2, which is 2.5. Okay, 2.5. So this value is not minimum value. No? This is your minimum value. Okay. So you substitute any value for a, you will get the value of this expression greater than 2 or equal to. Okay, so these are all the concepts of inequalities. Now let us move forward to the questions. Solve the inequations. So we want to find out the range of x, which satisfies both these inequations. Okay, which satisfy both these inequations. So what we have, 13x plus 5 less than equal to 18x plus 25. If I take 13x over here, I'll have 5x, and 20 over here, I'll have minus 20. So 20 minus 25 plus 5 is minus 20, and this is greater. So x is greater than equal to minus 4. X is greater than equal to minus 4. So let us try to plot it on number line. This is minus 4. This is the range. Okay. Now try to solve the second question, which is 11x minus 17 less than equal to 7x minus 29. So minus 29, if it comes here, it will become 12, and it will become 12. And 11x, if it goes here, wait, we can solve it in a better way. So what we have, 7x, if it comes here, we'll be left with 4x, and minus 17 if it goes here. So it is minus 29 plus 17. So minus 12. So x should be less than or equal to minus 3. Minus 12 by 4 is minus 3. So let us say we have minus 3 over here. So minus 3, it comes and becomes something like this. Minus 3, it comes and becomes something like this. Okay. This is the common range now, minus 4 to minus 3. This is the common range where both the inequations are satisfied. So what do we say? X belongs to minus 4 to minus 3. Now round bracket or closed bracket? Closed bracket. Why? Because minus 4 is also included, minus 3 is also included, because we have equal to sign over here. Okay, let us try to solve the second question. We have 5x minus 8 less than equal to 9x minus 30. So 5x, if it goes here, will become 4x, minus 13 if it comes here, will become 5. So this is x, and this is 5 by 4. So x should be greater than 5 by 4. Next thing is 15x plus 28 should be greater than or equal to 8x minus 50. So 8x, if it comes here, remains 7x. 28, if it goes here, minus 28 minus 15, which is minus 43. So x is greater than or equal to minus 43 by 7. So what do we have? What do we have? First is 5 by 4, and all the values greater than 5 by 4. Correct? So this is 4x. This is 5. All the values greater than 5 by 4 will work. Next is minus 43 by 7. All the values greater than this will work. So the common range is this after 5 by 4. So x belongs to 5 by 4 to infinity. Now that we have greater than or equal to, we will use a round bracket, closed bracket over here, and up to infinity. So infinity cannot be contained in closed bracket, so we use a round bracket over here. Moving forward to third question, I'll be erasing it. Third question is 3x plus 7 greater than equal to 5x plus 9. If I take 3x over here, this will become 2x. If I take 9 over here, this will become minus 2. So this is x is minus 2 by 2, which is x is less than or equal to minus 1. Next thing which we have is 7x plus 3 greater than equal to 4x plus 15. So 4x, if it goes here, it will be 3x, and 3 if it comes here. So this is 12. So x is greater than equal to 4. So what do we have? X first is minus 1. Minus 1, x should be less than minus 1. So this is the range. And then we have 4. X should be greater than or equal to 4. This is the range. There is no common ground, or there is no overlap in the values that will solve both the inequalities. That is why we say that this is a null set. None of the values of x satisfies both the inequalities. None of the values of x satisfies both the inequalities. So none of the values of x satisfies both the inequalities, and that is why it is a null set. Okay, that is why it is a null set. Moving forward, now let us try to solve the inequations, quadratic inequations. Here also we have to find out the range of x. Here also we have to find out the range of x. Now that we are going to find the range of x, first we'll have to convert it in this format, x minus alpha into x minus beta. Only then we'll be able to proceed. So let us try to do that. So what we have, x square minus 5x minus 14 less than equal to 0, which is x square minus 7x plus 2x minus 14 less than equal to 0. The way we used to solve quadratic equations, same method we are applying here. So that is x common x minus 7, here 2 common x minus 7 less than equal to 0. So we have x minus 7 common into x plus 2 less than equal to 0. Let us try to plot it over here. What we have, positive 7. Yes or no? We'll be using positive 7. And this is x plus 2, so it will be minus 2. Try to find out the value of try to find out any one value. So let us say x is equal to 0. So if I put x is equal to 0, this is minus 7 multiplied by 2, which is minus 14. Is it less than equal to 0? Yes, it is less than equal to 0. So this range works for us. If this range works, this range will not work for us. Why? Because the ranges are alternately acceptable, not acceptable. Okay, so the range for which this function is, the range of x for which this inequation satisfies is minus 2 to 7. Now that we have equal to, we'll take closed brackets. Next, what we have, 5x square minus 13x plus 6 greater than equal to 0. So which is 5x square minus 10x minus 3x. Minus 10x minus 3x is minus 13x, and minus 3 into minus 10. Minus 3 into minus 10 is positive 30, and 5 into 6 is also positive 30, greater than equal to 0. So 5x common x minus 2 minus 3 common x minus 2 greater than equal to 0, which gives me x minus 2 common 5x minus 3 greater than equal to 0, which can be written as x minus 2. If I divide by 5, this will become x minus 3 by 5. And 0 divided by 5 is 0 only. And I can add or subtract or multiply or divide by a positive value. It does not change the nature of the inequality. Now what do we have? Just plot this. So this is 3 by 5 and this is 2. Try for any value. So we generally try for 0 because it helps us solve the inequality easily. So if we get x is equal to 0, so this is minus 2 into minus 3 by 5, which is positive 6 by 5, which is greater than or equal to 0. So this range works. If this range works, definitely this range will not work and this range will work. So x belongs to minus infinity to 3 by 5. This is closed bracket, and for minus infinity we have round bracket. Union 2 to infinity. Union 2 to infinity. So this is how we need to do it. Next thing, third question. I'll be erasing it and trying to solve the third question. So third question is x square minus 4x plus 1 less than 0. Okay, so this is less than 0. Now try to understand that we won't be able to do it using that method wherein we split these two terms. And splitting the terms is not possible here. But eventually we want to find out the roots. How do we get that? X is equal to minus b plus or minus under root of b square minus 4ac upon 2a, which is minus of minus 4 is positive 4 plus or minus under root of b square, that is minus 4 square is 16, minus 4 into a is 1 and c is also 1 upon 2a, which is 2 into 1. So 4 plus or minus under root of 16 minus 4 is 12 by 2. With 4 plus or minus 2 root 3. Yes or no? 12 can be written as 4 into 3. 4, if it comes out of the root, will become 2 upon 2. So this is 2 plus or minus root 3. And if I divide by 2. So I've got two roots for x. X is 2 plus root 3. And other one is x is 2 minus root 3. 2 minus root 3. Okay, 2 minus root 3. So 2 plus root 3, 2 minus root 3. Let us try to plot it. 2 minus root 3. And this is 2 plus root 3. Yeah. Take any value between this range or out of this range. Let us try to take 0. Definitely 0 will be smaller than 2 minus root 3. Why? Because root 3's value is 1.71, 1.73, something like that. Okay, so 2 minus root 3 will still be positive. Okay, if I try for 0, if I substitute the value of x is equal to 0 in this equation, this is my equation only now. So this is 0 minus 0 plus 1 less than 0. So this equation is not getting satisfied. So this range is not getting satisfied. Definitely this range should also not get satisfied. And the range in between should get satisfied. So x belongs to 2 minus root 3. Here we will have round brackets. Why? Because we don't have equal to sign over here. 2 minus root 3 to 2 plus root 3. It will lie in this range. 2 minus root 3 and 2 plus root 3, it will lie in this range. Okay. Moving forward, how to solve these type of questions. Now, more than quadratic equation, we can move ahead further. So we have x plus 6 into x minus 7 into x plus 4 less than equal to 0. Just plot these values. We will get minus 6. Then we will get minus 4. And we'll also get positive 7. What do we try for? Generally, we try for 0. If x is equal to 0, this will become 6 minus 7 plus 4. So that is minus 42 plus 4 is minus 168. Is this less than equal to 0? Yes. So this range works for us. So this range will not work, this range will not work, and this range will work. Total, there are 4 ranges here. Minus infinity to minus 6, minus 6 to minus 4, minus 4 to 7, and 7 to infinity. Total, there are 4 ranges. So now x belongs to what? X belongs to minus infinity to minus 6. Here we will have close bracket, here we will have round bracket. Union minus 4 to minus 4 to positive 7. Okay. Why we have taken round bracket? Because we have equal to sign over. Okay, this is how you can solve the first question. Moving forward with the second question. Okay, I'll be erasing it. You are supposed to pause the video, try to solve it yourself, and then look at the solution. So this is the second one. 3 minus x to the power 5 into x plus 5 to the power 7 and x plus 8 to the power 2 should be greater than 0. Now, for this thing to be greater than 0, this thing, so x plus 8 whole square is already positive, which is going to be greater than 0. So this thing is not going to be useful for me. So all the positive values are not going to make any difference in inequality. We have already seen this. All the positive values are not going to make any difference in inequalities. We have already seen this. Okay, so let us try to find out how many positive values can we have. So can I make it like this? 3 minus x to the power 4 into 3 minus x plus 5 to the power 6 into x plus 5 into x plus 8 whole square greater than 0. So this is already positive. No need to check. This is already positive. No need to check. This is already positive. Okay, because anything raised to 4 is going to be positive. Anything raised to 6 is also going to be positive. And anything raised to 8 is already positive. It is a square value. So we just have to check whether 3 minus x into x plus 5, whether this is positive or not. And we have to check for this inequality. just multiplying it by -1. So if I multiply by -1, what will happen? This will become x minus 3. This is already x plus 5 as it is. And this 0 is also multiplied by -1, which will give me 0 only. But as soon as we multiply by a negative value, as soon as we multiply by a negative value, the inequality changes its nature and it will now be reversed. Okay, so we have this inequality x minus 3 into x plus 5 less than 0. Let us try to plot it. This will become -5, this will become positive 3. What do? We generally try for 0. So this is -3. When x is equal to 0, this is -3, this is 5, which is -15, which is less than 0. So it will work for this range. If it is working or if it is acceptable for this range, it will not be acceptable for this range. So x belongs to -5 to 3. We don't have equal to sign, so round bracket. So for all the values between this range, this condition will be satisfied. All the values between this range, the condition will be satisfied. Moving forward, let us try to solve this. X square plus 8x plus 24 greater than 0. X square plus 8x plus 24 greater than 0. Now, let us try to understand that we cannot find out the roots by splitting the middle term. And we are not able to find out the roots by splitting the middle term. So, what do we do in such cases? What do we do in such cases? We will just find out the roots using this method, minus b plus or minus under root of b square minus 4ac upon 2a. This is minus b is -8 plus or minus under root of b square. So 8 square is 64 minus 4 into a is 1 and c is 24 divided by 2 into 1. Now this is -8 plus or minus under root of 64 minus 96. No? So this term is 96. 64 minus 96 is -32 upon 2. Now the roots are imaginary. This is an imaginary value. This is an imaginary value. As this is an imaginary value, it cannot be plotted on. It cannot be plotted on number line. It cannot be plotted on number line. We have to understand this. As it cannot be plotted on number line, there is no value of x or there is no real value of x which satisfies this inequality. Okay, there is no real value of x which satisfies this inequality. So x belongs to a null set. X belongs to a null set. Okay, let us try to do it for this. Okay, let us try to do it for this term. Okay, x square minus 7x plus 55 less than 0. So x would be minus b. So minus of -7 is positive 7 plus or minus under root of -7 square is 49 minus 2, 4 into 1 into 55. Again, this bracket is also going to come as negative. And this is 7 plus or minus under root of 49 minus 220. That is -171 divided by 2. As again this is imaginary, no real roots are possible. So x belongs to null set. X belongs to null set. Moving forward, how to do this? X plus 3 into x minus 5 upon x minus 7. X plus 3 into x minus 5 upon x minus 7 greater than equal to 0. Now you must be thinking, let us say we multiply x minus 7 by 0. We multiply x minus 7 by 0. And with this, we'll be left with only the numerator. But this is wrong. Why? Because if this is a positive value, if x plus 7 is a positive value, then there is no harm. We can do that. And we can just take this value and multiply it by 0. But what if it is a negative value? If it is a negative value, then we'll have to change the roots and change the nature of the inequality. if this is a negative value and if we multiply by a negative value, we know that the inequality changes its nature. So we'll have to do that. है? But we don't know whether x minus 7 is positive or negative. So what we do, we do a process in which we make sure that the denominator is always positive. Yes or no? Let us try to do that. X plus 3 into x minus 5 upon x minus 7 we have. If I multiply and divide by x minus 7, it should be greater than equal to 0. So what we get, x plus 3 into x minus 5 into x minus 7 upon x minus 7 square greater than equal to 0. Now we have made sure that this thing is positive. X minus 7 square is positive. And this thing I can do multiply and divide by any value because I am doing it on one side of inequality. I am doing it only on left hand side of inequality. Okay, I am not doing it on right hand side of inequality. So I can do this. Now that x minus 7 is positive, x minus 7 square is positive, I can just multiply it here and it will become 0. And now what I have to check for x plus 3, x minus 5 and x minus 7 greater than equal to 0. We have to check for only this range. Okay, we have to check for only this range. Now that we are checking only for this range, what we get? Minus 3, this is 5, this is 7. Okay, we generally check for 0. If I put x is equal to 0, I'll have 3 into minus 5 into minus 7, which is minus 105 plus 105. Because this minus minus will get or become positive and greater than equal to 0. If you see, there are 4 ranges here: minus infinity to minus 3, minus 3 to 5, 5 to 7, and 7 to infinity. Okay, so minus 3 to 5, it will work in this range or it will be acceptable. All the values in this range will be able to satisfy the equation. Next thing, if it is satisfying in this range, it will not be satisfying in these 2 ranges, and again it will start satisfying in this range. So x belongs to minus 3 to 5, which is a round closed bracket because we have equal to union 7 to infinity. So close bracket for 7 and round bracket for infinity, because we cannot use round bracket for, we cannot use close bracket for infinity. Moving forward, second question, 2x plus 5 upon x minus 3 minus 4 greater than equal to 0. Hannah, what you were saying, if you want to multiply it by 4, what will happen? It can either remain as it is, or if x minus 3 is negative, it will change the nature of the rule. It will change the nature of the inequality, which we don't want. Okay, it will change the nature of inequality, which we don't want. So what we have, 2x plus 5 minus 4 into x minus 3 upon x minus 3 greater than or equal to 0. We always want to make the denominator positive. Before that, what I do, 2x minus 4x is minus 2x. 5 plus 12 is 17 upon x minus 3 greater than equal to 0. We cannot directly multiply by x minus 3. So what we have to do, we have to make the denominator positive. How do we do that? Minus 2x plus 17 multiplied by x minus 3 upon x minus 3 multiplied by x minus 3 greater than equal to 0. This I can do because I am doing this operation only on left hand side, and I am multiplying and dividing by a certain value. So minus 2x plus 17 into x minus 3 upon x minus 3 square is greater than or equal to 0, which makes me minus 2x plus 17 into x minus 3 greater than or equal to 0, because this is a positive value and we can multiply and divide by positive value without changing the nature of the root. Okay, Now what equation do I have? Minus 2x plus 17. No, I can do this by 2x minus 17. What I have done, I have just multiplied it by minus 1. This x minus 3, it's still there. 0 is still there because I am multiplying this 0 by minus 1. But now the root will change the inequality will change its direction. Okay, the inequality will change its direction. We have to work on this. Okay, if I divide by 2, I'll have x minus 17 by 2 into x minus 3 less than equal to 0. Just plot it. We have 3 and 17 by 2. We have 3 and 17 by 2. If x is equal to 0, so this will become x is equal to 0. So this will become minus 17 by 2 and minus 3, which is equal to 0. Is it less than equal to, which is equal to positive 51 by 2, not equal to 0. Is it less than equal to 0? No. So this range will not work. This range will work. This range will not work. Okay, this range will not be acceptable. So x belongs to 3 to 17 by 2. And these two values are included because we have equal to sign over it. Okay. Moving forward. Mod of, now here we have merged mod and inequalities both. Okay. So this modulus can be opened in two ways. So what we have, mod of 5x plus 3 less than equal to 23. So it can be 5x plus 3 less than equal to 23, which is 5x less than equal to 20, which is x should be less than 4. Or the other way it can be opened as mod minus of 5x plus 3 less than equal to 23. If I multiply by minus 1, I get 5x plus 3 and this becomes minus 23 and the mod will change its inequality will change its nature and will become greater than equal to. So 5x is greater than minus 26, which will give me x greater than minus 26 by 5. Okay, so if we have this as 4, so all the values less than 4 will work. And then we have minus 26 by 5. All the values greater than minus 6 by 25 will work. So now here we don't have to check the common area. Here we have to tell whether is there any area which is not acceptable. So actually x belongs to minus infinity to infinity in this case. Okay, because if you put, let us say, if you put the value as 5, this will still satisfy the equation. No, if you put value as 5, so that this will become 25. No. We have to consider the common area only. We have to consider the common area only. Okay, so to consider the common area, x belongs to minus 26 by 5 to 4, which is in closed bracket. Next is 7x plus 19 greater than equal to 33. Okay, 7x plus 19 greater than or equal to 33. This is a mod value. It can open something like this: 7x plus 19 greater than or equal to 33, or minus of 7x plus 19 greater than equal to 33. This gives me 7x greater than equal to 14, which gives me x greater than equal to 2. Then we have 7x plus 19 and this becomes minus 33. What we have done, we have multiplied both sides by minus 1. With this, the inequality will change its nature and it will become something like this. So 7x less than equal to minus 52 by, so 19 if it goes here, minus 52, x will be minus 52 by 7, minus 52 by 7. Let us plot these values, minus 52 by 7 and this is 2. It should be less than or equal to minus 52 by 7. It should be greater than, 2. Now here if you substitute any value of x, let us say 3, 4, this modulus will be satisfied. So here x belongs to minus infinity to minus 52 by 2, minus 52 by 7. This is round bracket, this is a union 2 to infinity. Okay, this is how you need to solve it. Moving forward, we just have to solve these quadratic equations. It is very easy, and these are quadratic equations. How will these brackets open? Mod of x square is obviously positive, so this is going to be x square minus 7x plus 12 equal to 0, or it can be x square plus 7x plus 12 equal to 0. Both of these are almost similar. How do we do that? So this is, how do we solve the quadratic equation? This is minus 3 minus 4. Second step, minus 3 by 1 minus 4 by 1. Third step, positive 3, positive 4. Okay, so these are the roots of x. Okay, which satisfy these inequality. Next, what we have? So, first minus positive 3, positive 4. Sum is positive 7, product is positive 12. Second is 3 by 1, 4 by 1. Third step, change the sign, minus 3, minus 4. Okay, minus 3, minus 4. These are also the values of x which will satisfy. So x will take the values minus 3, minus 4, 3 and 4. Okay. Now this equation is also same. It will one time become like this and other time it will become like this. So these two equations are nothing but the same. And you will get the similar solution for that. Okay, now x square minus 7x minus 30. So x square minus 7x minus 30 equal to 0, or x square plus 7x minus 30 equal to 0. What will be the split? First step, it will be minus 10 plus 3. Second step, minus 10 by 1, 3 by 1. Third step, change the sign. So this is positive 10, negative 3. Then what we have? Positive 10, negative 3. Sum is positive 7, product is minus 30. Second step, 10 by 1, minus 3 by 1. Third step, change the sign. So this is minus 10, this is positive 3. So all the values that will satisfy are 10, minus 3, minus 10, and positive 3. These values of x will satisfy the quadratic equation. Moving forward, f of x is equal to 32 plus mod 5x plus 7. We have to find the minimum value of f of x and the value of x for which it is minimum. So f of x is equal to 32 plus mod of 5x plus 7. This is a positive value. This is also a positive value, or 0. If I take these two positive values, the value will be greater than 32. The value will be greater than 32. If I take this positive value and 0, the value will be 32 only. And we want to find out the minimum value. So to find out the minimum value, this value should be 32. And it will be obtained when mod of 5x plus 7 is equal to 0. It will be obtained when mod of 5x plus 7 is equal to 0. Which gives me 5x is equal to minus 7. X is equal to minus 7 by 4. So minimum value of the function is 32, and it is obtained when x is equal to minus 7 by 5. Okay, then we have f of x is equal to 15 minus mod of 7x plus 4. Here we want to find out the maximum value. This is a positive value, this is a positive value, or 0. So if I take positive and positive, so this will not be the maximum, it will be always less than 15. If I subtract 0 from 15, the maximum value I'll get is 15. The maximum value I'll get is 15. Okay, now that this is the maximum value, where do we get this maximum? When mod of 7x plus 4 is equal to 0. So 7x plus 4 should be equal to 0, which gives me 7x is equal to minus 4, which gives me x is equal to minus 4 by 7. Okay, so we'll get the maximum value of f of x is 15 when x is equal to minus 4 by 7. Okay, moving forward. If f of x is equal to, for all this, we have to find the minimum value of f of x. Also, we have to find out the values of x for which f of x attains the minimum value. So let us try to solve it. So to find the maximum and minimum value of these functions. Okay, so find the minimum value of f of x. This also find the value of x at which f of x attains the minimum value. So now f of x is mod x minus 4 plus mod x minus 7 plus mod x minus 10. Correct. Now all these are positive values, correct? All these are positive values. Okay, at any given point of time, any one of these mods will be 0. Okay, at any given point of time, any one of these mods will be equal to 0. So when I put x is equal to 0, x is equal to 4, this first modulus value will be 0. This is 3 and this is 6. Total is 9. This is your f of x. If I put x is equal to 7, I'll get f of x is equal to 3, 0, 3, that is 6. And when I put x is equal to 10, I get f of x is equal to 6, 3, 0, which is again 9. So now, from this, what do we understand? That minimum value of f of x is this, and it is obtained at x is equal to 7. It is obtained at x is equal to 7. Next, if we have to try, f of x is equal to mod of x minus 8 plus mod of x minus 12. Either this bracket should be 0 or this mod should be 0. If I put x is equal to 8, I get f of x is equal to, 0 plus 4, that is 4. But if I put x is equal to 12, f of x is equal to 8. F of x is equal to 4 plus 0, which is again 4. So I am getting it for 8, I am getting it for 12 as well. So in such cases, we'll check for all the values between them as well. And in such cases, we'll check for all the values between these two. So f of x in this case is going to be 1 plus 3, that is 4. F of x in this case is going to be 10 minus 8 is 2. 10 minus 12 is minus 2, which is 4. And f of x in this case is 11 minus 8 is 3, and 1 minus 11 minus 2 minus 1, that is 4. So all these values are able to give me f of x as 4, and f of x as 4 is the minimum value. And as it is the minimum value, we can say that minimum value of f of x is 4, and it is obtained at 8, 9, 10, 11, and 12. Next thing which we have to understand here is mod of x minus 5 plus mod of x minus 8 should be less than 3. Now, how do we do that? Say, if we try to find out the minimum value of this, what will be the minimum value? Either we'll put x is equal to 5, which will give f of x is equal to 0 plus 3 is equal to 3. Or if I put x is equal to 8, I'll get f of x is equal to 3 plus 0, that is 3. If I put any value between them, x is equal to 7, x is equal to 6, I am going to get f of x is equal to 3. Hai. So this is the minimum value, just like we found out here. This is the minimum value. Now, if 3 is the minimum value, then This expression being less than 3 is not possible. This expression being less than 3 is not possible. And hence it has no solution or no value of x satisfies. No value of x satisfies it. Okay, this is how you need to do it. Moving forward, we have to solve this. What we have, mod of x plus 5 should be less than 3x minus 8, which is x plus 5 should be less than 3x minus 8, or the other case should be minus of x plus 5 should be less than 3x minus 8. So what we have, if I take x over here, I'll have only 2x, and minus 8 over here, it will become 13. So this x, one second. So this x is 13 by 2 or 16.5. Then I take minus x over here, it will become 4x. And I can add and subtract with negative value, there is no issue with that. And I take minus 8 over here. So minus 8 will become plus 8 minus 5 is 3. So what do we get? X is greater than 3 by 4. X is greater than 3 by 4. So if I draw it, this is 13 by 2. X should be greater than 13 by 2. X should also be greater than 3 by 4. So this is the common range for this value, or for all the values between 13 by 2 to infinity. 13 by 2 to infinity, the uh, value of this, I mean, that value of x satisfies this inequality. Okay, that value of x, it satisfies the inequality. Now, find the minimum value of this. Now, I'll tell you a lengthier method, and then I'll tell you how we can solve it in the exam. Okay, we have to find the minimum value of this. How can I do it? I can write x into y square plus z square upon xyz plus y into x square plus z square upon xyz plus z into x square plus y square upon xyz. So this x gets cancelled, this y gets cancelled, this z gets cancelled. Y square upon yz is y upon z, z square upon yz is z upon y. Correct. Then x square upon xz is x upon z, and z square upon xz is z upon x. Then x square upon xy is x upon y, and y square upon xy is y upon x. Okay, this is nothing but y by z plus 1 upon y by z. Similarly, this is x by z plus 1 upon x by z. And this is x by y plus 1 upon x by y. Correct? So what do we have? A plus 1 by a. A plus 1 by a is equal to, I mean, it is greater than or equal to 2. And a plus 1 by a is greater than or equal to 2. Okay. Now, minimum value of this expression is 2. So similarly, this is also in that format, a plus 1 by a format. Minimum value for this expression will be 2. Similarly, minimum value for this expression will be 2. Minimum value for this expression will also be 2. Okay. From this, what do we get? From this, what do we get? We can say that minimum value of this overall function is equal to 6. Minimum value of this overall function is equal to 6. But one small trick I am telling you, whenever they are asking me to find out minimum value, or whenever they are asking me to find out a maximum value of anything, what we generally do, we equate the what to say, we equate the variables. So what I'll do x plus y plus z. X is equal to y is equal to z. है ना? Irrespective of what they are asking. If they ask me minimum value, if they ask me maximum value. Because there is only one case in which you can get minimum value, and there is only one case in which you can get maximum value. That case is taken care by them. है ना? We don't have to remember that. And in both the cases, you will get the minimum value or maximum value respectively by equating the variables. Okay. You don't have to remember when it is minimum value, when it is maximum value. Just equate all the variables. In 90% of the questions, you will get the answer. So what you have, this is x, everything is x now. So x into x square plus x square plus x into x square plus x square plus x into x square plus x square upon xyz, that is x cube. So this is how much? 2x square into x, that is 2x cube plus 2x cube plus 2x cube, that is 6x cube upon x cube is 6. Okay. So this is your minimum value. Similarly, find the minimum value of this. Find the minimum value of this. Just equate a equal to b equal to c. A equal to b equal to c. This is how you are going to solve in the exam. There is a lengthier method of arithmetic mean and geometric mean, and you can do it in that fashion as well. Okay, you can do it in that fashion as well. But just equate a square is equal to b square. A is equal to b is equal to c. So what I have, a square plus a square upon a square, a square plus a square upon a square, and a square plus a square upon a square, which is 2a square upon a square, 2a square upon a square, 2a square upon a square, a square, a square, a square, a square, a square, a square gets cancelled. We get the value as 6. We get the value as 6. Simple as it is. Okay. Then again, find the minimum value of x plus y. Just do this. X is equal to y is equal to z. What do you get? Just look at it. X is equal to y is equal to z. You will have 2x plus multiplied by 2x multiplied by 2x divided by x cube, which is 8x cube upon x cube, which is 8. This is the minimum value of the expression. Okay, simple enough. Now, x square plus y square plus z square is equal to 6. Find the minimum value. This can be done using your conventional method. It can also be done using your arithmetic mean and harmonic mean method. Okay. So if I use x square plus y square is equal to plus z square is equal to 6. Now this is 3x square, because I am saying x is equal to y is equal to z, which is equal to 6. So x square is equal to 2. Now 1 by x square will be 1 by 2. 1 by y square will also be 1 by 2. 1 by z square will also be 1 by 2. Total is 3 by 2. Total is 3 by 2. Okay. Now that we have total is equal to 3 by 2. So your answer minimum value is 3 by 2. Now let us try to understand the conventional method. Arithmetic mean is always greater than or equal to harmonic mean. We know this. Arithmetic mean of x square and y, x square plus y square plus z square will be something like this. Harmonic mean will be 3 upon 1 by x square plus 1 by y square plus 1 by z square. Okay. Now we know that x square plus y square plus z square is 6 by 3 greater than equal to 3 upon 1 by x square plus 1 by y square plus 1 by z square. Okay, which is 2. If I can take it here because this is a positive value, yes or no? And I can multiply and divide by positive value without affecting the nature of the root or nature of the inequality. So 1 by x square plus 1 by y square plus 1 by z square is it greater than or equal to 3, and this 2 will come below 3 by 2. Minimum value is 3 by 2. Yes or no? Minimum value is 3 by 2. Now you have to decide whether this method is better or this method is better. I am not saying that this method is going to give you answers in 100% of the cases, but 90% of the cases are good enough to get the answer, and that is a sufficient criteria to remember that method. Correct? Now last two questions. Which one is greater? Okay, which one is greater? Which one is greater? simple calculation or simple trick which I want to tell you is, if a raised to b and b raised to a, these type of questions are there or these type of values are there, then whichever whichever what you say, whichever power is higher, that value is higher. है ना? Now there are some exceptions. What are those exceptions? Like 2 raised to 4 and 4 raised to 2. है ना? If whichever power is higher, that value is higher. According to that, 2 raised to 4 should have been higher. But these two are equal. 2 raised to 3 and 3 raised to 2. According to the rule which we are having or the property which we are using, whichever power is higher, that value is higher. According to that, this should be higher. But now, actually, 3 raised to 2 is greater than 2 raised to 3. Na? 9 is greater than 8. 9 is greater than 8. Now, if we check for any value, 3 raised to 5 and 5 raised to 3, this one will be greater. Wherever the power is greater, 7 raised to 10 and 10 raised to 7, this one will be greater. Wherever the power is greater, that value will be greater. So here the power is greater, so hence this value will be greater. Next, we have to find the range. We have to find the range of x, y, and range of x and y is provided to us. So x into y, we have to do. So x can take minimum value as -3, y can take minimum value as -5, or x is -3, y is 6, or x is 7, y is -5, and x is 7 and y is +6. So x into y, this is -15, this is positive. In fact, this is +15, this is -18. Yes or no? This is +15, this is -18, this is -35, and this is +42. So simple, the range is -35 to 42. The range is -35 to 42, round bracket. Okay, this is what we have in inequalities. Okay, so you can, if you have any doubt, you can connect with us on the given numbers. Thank you so much. Jai Hind.